Welcome to Knowledge Share channel. In this video, we will be discussing about UPS, that is uninterruptible power supply. So, which is the most important equipment in today's era. UPS, that is uninterruptible power supply, is the most important equipment where it is used in almost all the industries, household applications, and everywhere. So we will be discussing about what are its different types, and we will be discussing about the block diagram, and one design problem also we will be discussing, so that you will be having a clarity of how to design a UPS for the given load. So how what will be the magnitude of the UPS, or what will be the rating of UPS. So those things also will be discussed, and finally we will be discussing about what are the different batteries that are more suitable for your particular application, because UPS uses a battery. So which battery will be useful for your particular application? This is what the entire video is all about. Okay, so the topics covered are so here, what is UPS, how does an UPS works, and what are the benefits of using UPS, and what are its types, and finally we will be discussing about the UPS block diagram, advantages and disadvantages of the online UPS also will be discussed, and one design problem will be discussed. So this is the overall outline of the video. Okay. So as you know, what is a UPS? So UPS is nothing but it is an electronic power supply. It is an electronic power supply which enables some loads to continue operating for at least a short period of time when the incoming power is interrupted. See, for example, there are many reasons for the incoming power to be interrupted. Okay. So suppose if it is getting interrupted, there are many loads which are called as critical loads, which will lead to loss of data or loss of quality. So in order to ensure that the power supply is always available and it is not interrupted, so we have to use electronic power supply which is called as uninterruptible power supply. So nowadays, you know, the UPS is used in almost every houses as well in industries, because we are not confident of the grid power. The grid power may fail at some times, and if the grid power fails, whatever work that is being carried out in household or as well as in industrial, that should not get the quality should not be compromised, that process should not be disturbed. So in order to ensure that, we are using the UPS. So UPS is nothing but it supplies electricity from an energy that is stored in a battery. So UPS is nothing but which has to supply the electricity when the grid power is interrupted, and that power is supplied through the battery. So this is what the UPS is all about. So normally where this UPS will be there. So the UPS will be mainly in between the source and load. Okay, so load will be at the last, okay, and source will be at the start, and in between you will be placing the UPS. So the UPS will be always tracking whether the power supply is available or not. If the power supply is suddenly not available, immediately the UPS will be giving this, that is, it will be transferring the energy from the battery to the load. Whenever the power supply is getting interrupted, it will transfer the electricity from the battery, that is which is having the stored energy in battery, to the load. Okay, so this is the function of UPS. So how does it works? So UPS, how does it works is because, see, normally all the batteries can store the power in the form of DC only. So we have to convert the energy, that is AC energy, to DC. Okay, so AC energy has to be converted to DC. So only then we can charge the battery, and only when the battery is charged, and so during the interrupted condition or during the grid outage, we can make use of this stored battery energy and again it has to be converted to AC. So, for that we will be using an inverter. Okay. So, we need a charger in order to charge the battery. So, charger is nothing but which is going to convert the AC supply to DC, because DC will be stored in battery. And now during the outage, this battery will be supplying to the load, but the load will be able to absorb only the AC power, and because of which we want to convert the battery DC output power to AC. So, for which we will be using an inverter. So, a UPS will be having three main components. One is rectifier or charger unit, which will be converting the AC to DC. The second one is battery unit, which is going to store the energy. Whenever the power supply is available, it will get charged, and whenever the power supply is not available, that DC power will be converted to AC power using the inverter. So, three main components. One is rectifier or charger unit, the second one is battery unit, the third one is inverter unit. So, these are the three main components in the UPS system. Okay. So, maybe this UPS, there are many types are there. Okay. So, we will be discussing one by one. Okay. So, let us go into what are the benefits. So, what are the benefits, as you all know. So, because the quality of output should not be disturbed. So, now let us go into the different types. Okay. What are the different types? So, the UPS is classified into three different types. Okay. One is online UPS, the other one is offline UPS, and the third one is line interactive UPS. Okay, these are the three different types actually. So, each and every type is having its own plus and minus, and we have to decide based on our requirement, based on our application, we have to decide which type of UPS will be suitable for our particular application. So, UPS, three different classifications: online UPS, offline UPS, and line interactive UPS. So, now we will be discussing one by one, and later we will be understanding which type of UPS will be useful for our particular application. So, now we will go into the how it works and what is the significance of behind how it works. Okay. So, here you can see that this is the first diagram. So, this is the first diagram. So, in the first diagram it is nothing but the normal mode. What do you mean by normal mode? That is, the grid power is flowing. So, here the left side is the grid. Okay. So, this is the grid. So, here the grid is there. Okay. So, here the grid is there. I am just writing grid. Okay. And this is load actually, and this is load. Okay. This is the load. So, here grid is there, and you can see that the UPS is at the center. Okay. So, what are the different components? You can see the charger is there. So, charger will be charging the battery. Okay. So, charger will be charging the battery, and you can see that inverter is there, and see he can see he easily can understand the block diagram. See when so here you can see this is the normal mode. So, for the first one is normal mode. So, here you can see I have this is normal mode. So, in normal mode what happens is the grid power is actually available, the power is present. Okay. So, it is there, whereas during the UPS outage mode, so this is called as outage. So, you can see that outage. So, whenever the grid power is not there, okay, the grid power is not there. Okay. So, this is the second block diagram. So, this is the first block diagram. Okay. So, where we have the grid power available, and this is the second block diagram where the grid power is not available. So, when the grid power is available, you can see that the grid power will be charging the battery. So, you can see that battery will always take DC. Okay, it will be charged only using DC, whereas here in grid you will be having only AC. So, you need a charge. So, this charger and this charger is going to convert AC to DC. So, it is nothing but you will be having some rectifier and filter circuits, and finally you will be converting this AC to DC, and you will be charging the battery in DC. But what about the load? Actually, it is in the form of AC. Okay, the load is in the form of AC. So, this inverter what it is going to do is it is going to convert DC to AC. So, finally, you can see this is the switch. Okay, so this switch is playing a very vital role, and here also you will be having a sensor, and in that sensor it will be always sensing whether the grid supply is available. If the grid supply is available, this switch will be on top position. If the grid supply is suddenly interrupted or grid outage is there, it will be falling out like this. Okay. So, this is one of the important switch which is going to sense whether the switch is whether the grid supply is available or not. So, when the grid supply is available, it will be in up condition. Okay. The switch will be in up. When the grid supply is not available, it will be in down condition. Okay. So, here you can see that whenever the grid power is available. So, let us discuss about the first block diagram. So, whenever the grid power supply is available, you can see that the grid power will be flowing in two different directions. So, here one direction is there. Okay, I will just mark in a different color, okay, so that you can have a better understanding. Okay. So, here you can see that it will be in a different, so the grid power is divided into two different things. So, one is it is going directly to the load. The other one is you can see that here it is getting divided. So, this point, so at this point it is getting divided. The other point is it is going to charger. So, why this charger? So, it has to charge the battery. So, only when the grid power is there, the battery has to charge. Okay, so the battery will be charging during the on condition when the grid is on. And suppose if there is a shortage, if the grid power is suddenly off, as we have discussed, and suddenly the grid power is going off. Okay. So, what happens is this switch. So, this is the switch which is a very important switch. So, which is going to sense the grid power, and immediately it will change the switch to down condition. Okay, it will be switching down, and because of which you can see that what happens is the battery immediately. So, since the circuit has been closed, the battery will be supplying the power. So, from here to here, and from inverter and again to the load. So, why this inverter? So, inverter is going to convert this. So, DC. So, always you know that the battery is a DC, it is a DC power. Okay. So, DC power will be converted to AC, and finally you will be getting an AC output. Okay. So, the load is AC, so you have to convert DC to AC. Okay. So, always you can store the power only in the form of DC in battery. So, DC will be converted to AC using the inverter, and finally that AC load will be utilizing the power whenever the grid is off. Okay. So, this is how it works. So, this is the overall block diagram of the UPS. Okay. So, as we have already discussed, there are three different types. One is the online UPS. Okay. So, this is the first one, online UPS. The next one is offline UPS, and finally the line interactive UPS. So, these are the different three types. Okay. Three different types that is available in market. So, it's the block diagram. You can just see the block diagram. So, block diagram, you can see that So, these are, as I have already told, the three different components are there. So, this is the first important component, that is the rectifier or charger, and the second important component is battery, okay, and the third one is inverter. So, this is how it works, and finally this filter. So, this filter, this is going, because the inverter output will be having some harmonics. Okay, this here you can see that harmonics will be there. So, here it will be producing AC with harmonics will be there, whereas here pure AC will be developed. Okay, pure AC will be there. So, the critical load will be working fine. This is how this is the overall UPS block diagram. So, the UPS will be having a rectifier. Why we converted to rectifier is because this rectifier will be converting this AC to DC. Okay, AC to DC, and inverter, this will be converting DC to AC. So, here this will be converting DC to AC, and this AC will be having some harmonics will be there. So, this is the harmonics, and this harmonics will be filtered. Okay, this harmonics will be filtered by means of this filter, and finally you will be getting a pure AC, and this will be supplying to the critical load. So, this is the overall block diagram of the UPS. Okay. So, now let us go into the some other things. Okay. So, you know that what is the rectifier? So, it will be having a full wave rectifier or something like that. Okay. So, full wave bridge rectifier will be there, and here you will be having the filter. Okay, filter will be there. So, this is how the charger or rectifier unit will be there. So, what is the function of filter? You can see that filter will be having some signal and noise. Sorry. So, filter will be having some signal and noise will be there. So, you can see that this noise is the most important one. So, here the input waveform you can see that is highly distorted. Okay, this is the input. Okay, so this is the input waveform, and this is highly distorted. So, after using the filter you can see that it is a pure AC output. So, if you use this particular AC output, your load will be having less power loss. So, the load efficiency will be high. Whereas, if you give the same this input, okay, so this if you give this input, whatever is here without using the filter, then your load efficiency will be less. Okay. So, that is why always we want to use filter. So, filter is a very important component which converts the impure AC, okay, impure AC to pure AC. So, it will be having the impure AC, in the sense it will be having the noise, along with the input signal. So, that will be converted to a pure AC signal. So, so that your load will function correctly. So, this is how your UPS will be there. Okay. So, next before going into the advantages and other things, I just want to again brief something about online UPS, offline UPS and line interactive UPS. Okay. And then we will discuss about what are the different advantages. Okay. So, for example, if you take the offline UPS, so the offline UPS, it will be activated only when the main power is gone. For example, the main power is off. Okay. Only at that condition the offline UPS will be activated. So, the function of UPS, it will be supplying the load only during the grid outage conditions. So, because of which the offline UPS will be having lesser rating. Okay. So, because of which the cost also will get reduced. Okay, that is the main advantage. Okay. So, normally in household applications we will be using the offline UPS. The second type, that is called as online UPS. So, in case of online UPS, only see you can see that the inverter will be supplying to both the battery as well as the load. Okay. So, the grid will be directly converted to inverter. So, grid power will be converted to DC and it will be feeding to inverter, and this inverter will be feeding to both battery as well as the load. But the main thing is, the main advantage is, whenever you get the output from the inverter, always the grid power supply will be having some distortions in it. So, suppose if you need a load in which the distortion should be completely 0, then you can go with the online UPS. But the main problem is, since the inverter will be taking the entire load, okay, the rating of the inverter components as well the battery capacity should be very high, and because of which the cost of the online UPS is very, very high. Okay. And the third one is line interactive UPS. Okay. What is meant by line interactive UPS? It is having the cost somewhere in between the offline UPS and online UPS. So, line interactive UPS is nothing but, see, suppose when the grid supply is in the normal voltage range, okay, in the normal voltage range, then the UPS will be supplying only to your load. It will not be that is when it is in normal range. Okay, when it is normal range, the grid will be supplying. When the voltage range is between a normal range, then it will be supplying to the load directly. And whenever it is going out of the range, then the UPS will be activated. Okay, for example, if the input voltage is beyond a certain level or low voltage is there, then this UPS will be activated and then it will be supplying to the load. So, this what happens is, you can see that this particular line interactive UPS is the cost wise we are reducing the rating actually. The rating is not high compared to your online UPS, but slightly higher than the offline UPS. Okay. So, this is what all about. Okay. I will just tell you once again. So, online UPS, so here you can see that the UPS rating, okay. So, the UPS rating is less, okay. That is the inverter rating, okay. Inverter rating is less, battery is also less, battery capacity also less, and because of this the cost is also less, okay. But whereas in off, I am sorry, so this is for online, is it right? So, in this online, so this is online, okay. So, online UPS, you can see that the UPS rating will be high, I am sorry here, okay, whereas battery rating also will be high and also the cost also will be high. So, in case of offline UPS, you can see that the UPS rating will be less and battery rating will be less. So, cost also will be less. Whereas, line interactive UPS, only when there is a that is when there is a voltage, dip, slight dip is there or over voltage is there, only at that condition this line interactive UPS will be acting. Otherwise, the grid, since it is having a very good quality of power, directly it will be taken. Okay. So, this cost wise it is somewhere somewhere it is between online and offline UPS. Okay. So, it is moderate. Okay. So, it is moderate. Okay. So, this is what you want to understand cost. So, hope you are all clear with the difference between the online UPS, offline UPS and line interactive UPS. Okay. And so the main advantage, so what are the advantage of the online UPS? Nowadays, on almost all the industries they are using online UPS. So why it is offering going for the online UPS is because it offers continuous power flow, okay, and also there is a good isolation from the main power supply and also the end user. So if there is any fault in the main power supply, it will not affect the end user. And similarly, you can see that the electricity is continuously given, constantly given without any interruption to the load. And the third one is, suppose if there is any failure in the main power supply, okay, then it cannot change its operation mode. So the transfer time is very very less actually. There is no need for any transfer time. Whereas in case of offline UPS, there is a transfer time. Okay, the UPS has to change from one mode to other mode. So here there is no change of mode and all. So the transfer time is 0. So that is the main advantage. And also the input voltage is also a wide range you can achieve in case of the online UPS. So what are the disadvantages? As you all know, the disadvantages, it is, since the rating is very high, it will generate more heat. It will generate more heat, and because of which a larger heater sink is needed. So this is the main drawback. Complex design. So design is very complex, yeah, because the rate, whenever the rating is very high, then more protection circuits has to be added, and because of which the complex design is there. And very important is it is very very expensive, because the rating is very high, the expensive is very expensive, it is highly expensive, and power loss is quite high, okay, because and because of which the efficiency also might be reduced, as you all know that we are going for a very high rating. So this is one of the main drawbacks, okay, of online UPS. So these are the advantages and disadvantages of the online and offline UPS. So now let us go into how we have to decide the UPS power rating. Okay, so the UPS power rating, you can see that it can be calculated. First, you want to calculate. So, for example, in house, they will be saying what will be the rating of the UPS which has to be connected to my house. So, how we can calculate? See, there are different types of UPS available that in the market. So, here you can see that it is available in the 600 VA is there, 1 kVA is there, 1.5 kVA is there, 2 kVA is there, 6 kVA is there, 10 kVA is there, like that, okay, and 15 kV is also there, 20 kV is there. So like that it is there, but which is suitable for my home appliance? So as you go with higher rating, you have to invest more cost, and if you are not matching the rating with the correct load, then the losses will be high. Again, you can see that the UPS will be the life will be getting reduced. So always the load has to be matched. The load, whatever, for example, if your load is around 500 VA, then you can go with 600 VA. Okay, if your load is around some 900 VA, then you can go with 1 kVA. 1 kVA is like 1000 VA. So like that, slightly higher. But for example, if your load is only 500 VA, and if we are using 2 kVA, then that will result in a heavy loss, as well with the high initial cost and heavy loss, and the life of the UPS also will be reduced. So in order to avoid that, we want to always calculate what is the rating of the load, what is the rating of the connected load, and then we have to choose which particular UPS rating will be suitable for our load. Okay. So always you can see that the UPS power output will be, so this is a very important thing, I just want to emphasize on it. The UPS rating will be always given in VA, that is voltage ampere, that is volt ampere. Okay. So it is not given in kilowatts like your HP or kilowatts or something like that, like your motors and other things. So here the UPS power rating will be in the VA, that is volt ampere. Okay, it will be in the VA only. Okay, so now we will go with one design problem. So UPS design problem is there. So here in UPS design problem, we want to calculate what is the rating of the UPS. So you can see that you please calculate. So this is the question that has been asked in many of the university papers previously, in gate question papers also. So you have to calculate what is the rating of the UPS. So you can see that two 80 watt fan is there, and 4 number of 40 watt lights, tube light is there. So 4 number of tube light is there with 40 watt rating, and 2 number of fans is there with 80 watt rating. So how to calculate? So first, as I have told, we want to calculate the total load. So how to calculate? So since 2 number of fans are there, so here 2 fans into 80 watts per fan. So here you can get 160 watts. So similarly, lights, you have 4 lights. So 4 lights into 40 watts. So each light is about 40 watts. So I am getting again 160 watts. So if I just add, you can say the total load is again 160 watts fan is there, and 160 watt total load is light is there, and total load 320 watts is there. See, always, and you want to design. So next is so you have calculated the total load actually. So always, you should not keep the rating equal. Okay, so it should be slightly. You have to keep some margin. So the margin, it will be 20 percentage. Very, very important. So whatever total load you have calculated, always you want to multiply with 1.2. So finally you will be getting 384 watts is there. So this is the UPS rating. So as I have already told, the UPS rating should be in the VA. This is a very important. So I have changed it to 384 VA, that is volt ampere. Okay, so UPS rating I have found out. But what is the question that has been asked? You can see that 12 hours daily. So 12 hours means I have to calculate battery rating. Okay, again I have to calculate the battery, because I have calculated the UPS rating. Okay, UPS rating is 384. Then based on the battery rating only, okay, how much AH. So always the battery rating will be given in AH, that is ampere hour. So based on that, this number of hours can be changed. Okay, so we'll move on. Okay, so here hope you are clear. So the backup time, so the UPS backup time, that is 12 hours has been, so to ensure 12 hours, okay, depends upon the UPS battery capacity. This is a very, very important. So always, suppose it is 6 hours, you want to take it as 6 hours. Okay, so here in the problem it has been given as 12 hours. So to ensure 12 hours of continuous operation, you need the UPS with the sufficient battery capacity to support this 320 watts of the load duration. Okay. So now you can see that actually the load power, you can see that 320 watts is there. So here the 320 watts is the actual load power. Okay. So actual load power. So now there is that if you want to, there is some efficiency problem is there. Okay. UPS it will take some losses will be there. So always you want to divide it by 0.8. So if the losses has to be considered, it has to be divided by 0.8. Then your actual thing, that is, it will be 400 watts will be there. Okay. So there is a formula in order to calculate the battery capacity. So battery capacity can be calculated using a formula. So what is that formula? That is battery capacity, as I have already told, AH. So AH is nothing but ampere hour. Okay, it is nothing but ampere hour. So how much? So for example, if I am telling it is 1 amp hour, 1 AH, it means that 1 amps given for 1 hour, or half 0.5 amps that can be given for 2 hours. So similarly you can calculate. Okay. So this is what this AH is all about. So how you can calculate this AH? So he can see that what is the adjusted load power. So adjusted load power is 400 watts. So that can be substituted. Okay. So then what is the back time that is required is 12 hours. And finally, what is the battery voltage? So battery voltage normally it will be around 12 volts. So 12 hours is there, and 400 watts is what the adjusted load power. Okay, because the losses of the UPS has to be taken care. And finally, I have gotten the answer is 400 AH. So the battery capacity is, this is very important. That is, therefore the battery capacity of at least 400 AH should be used. Okay, in order to provide a 12 hours backup time. So in order to have the 12 hours backup time for a 320 watt load with the UPS efficiency, you can see that a 400 AH battery has to be used. Okay, then so this is the design problem. Then what type of battery I have to use? See, in market so many types of battery will be. So next session will be dealing about what will be the different types of battery, and what are the different types of battery, and which type of battery we can choose according to our requirement. So here you can see that normally you can see that there are 3 different types. So one is the VRLA battery. So this is called as VRLA battery. Okay, that is valve regulated lead acid battery. So this is the most frequently used one. And next is FLA batteries. Okay, that is nothing but flooded lead acid battery. One is valve regulated lead acid battery. The next is flooded lead acid battery. So then finally we will discuss about the lithium ion battery. So which is the most advanced technologies which is used nowadays, and that can be very useful, but with high initial cost will be there. So now we will go with VRLA battery. So the VRLA battery, again there are 2 different types. One is the AGM type, that is absorbed glass mat type. The next one is gel type. Okay. So here based on the electrolyte. So for example, if the electrolyte is made up of the fiberglass mat, then that is called as AGM. Okay. So then for example, if the electrolyte is made up of some gel or something like that, then it is called as gel type. Okay. So 2 different types of VRLA batteries are there. So what are the advantages of this VRLA battery? So you can see that it is sealed, so it is maintenance free. Okay, the maintenance very less in case of the VRLA battery. So that since no acids are there, you can see that there will be no risk. Okay, and performance was also very good even at high and low temperatures. So lifespan is very high. So this is the main advantage of the VRLA. But what are the drawbacks? So you need high initial cost will be there, and the discharge rate is very slow. Okay, so that is one of the main important drawback of this battery. Many researches are going on even today. So what is this? The next type is flooded lead acid battery. So here, so suppose if I am not possible to invest in a very high range, then I can go with the FLA batteries, which is having less cost. Okay, and also the main advantage is higher discharge rate is there. Okay, so good discharge rate is there. And similarly, what are the disadvantages? That should be disadvantage. So you can see that some regular maintenance should be there. So we want to top up the electrolyte in a very, for example, 15 days once or 20 days once or something like that. And there is a risk of this acid may be spilled outside, and because of which some risk may be there. Okay, and the lifespan is also quite less when compared to the VRLA batteries. So these are the main drawbacks of the flooded lead acid batteries. So next we will move on with the lithium ion battery. Okay, so what do you mean by lithium ion battery? So this is the most advanced technologies nowadays. Why? Because it is having high energy density. What is high energy density? So if you have high energy density, the volume will be very less. Volume will be less, weight also will be very less. That is why it is having high energy density. So for example, if the same rating, if you are preparing VRLA battery or FLA battery, the size and volume will be nearly 4 to 5 times higher when compared to your lithium ion battery. So that's why we say that the lithium ion battery are having high energy density. Lifespan is good. For example, it is having good lifespan is there, and faster recharge time. It can be recharged in a very fast time when compared to the other two types of batteries, that is VRLA as well as the flooded. And environmental friendly, not environmental friendly, but compared to other two types, it is good. Okay, that's what the main drawback. This disadvantage is high initial cost, and for very high temperature, it is not suitable because quite sensitive is there, because sometimes it may get exploded or something like that. Okay, so we have to take some preventive measures and other things will be there. So this is the main drawback of the lithium ion batteries. Okay. So how to choose the right battery is depends upon the application. So for example, if my application is very critical and high reliability is needed and longer lifespan is needed, then you can see that VRLA and lithium ion will be the better choice. Budget is the main concern. So for example, in some of the application, no, I need very less, I can invest in a very small, so then you can go with FLA battery. So FLA battery is budget friendly. Okay, so that is main important. So then you say, so suppose if you are having the space constraint, no, there is no very little space is only available. Then as you also that the lithium ion battery is the best choice because it is having very less volume as well as very less weight. Okay, because it is having higher energy density. Okay, the energy density is nothing but within a small volume you can get high energy. So energy density is very high. And based on environmental conditions, as we have already discussed, lithium ion batteries are better when compared to the other two types. Okay, I don't say that it is the best, but it is also having serious drawbacks, like it is very difficult to dispose and other things are there. But when compared to the VRLA and FLA batteries, lithium ion is having a upper hand in case of the environmental conditions. So that's all about today's discussion and in this video, and thank you very much for your patient listening, and hope you all understood the different types of UPS and how to design the UPS rating, and as well how to select the battery, and as well how to design the battery, how to decide the battery rating. So all those things we have discussed in this video. I am sure it will be very useful for you. So if you really like this video, please give a thumbs up, and as well if you have any clarifications, you can give some comments. And if you really feel that this particular video will be useful to someone, you can just share it. And if you like the videos which I post in this channel, you can just subscribe to my channel. So thank you very much. Thank you.